Okay, so we're going to be looking at independent events. So we're going to start off with an example here. So who in this class, so right now, how many students do we have today? Maybe more than 12? 1, 5. No, we have 12 again. So I know I have 12 students in today's class. How many of you are left-handed here? Raise your hand if you're left-handed. Mike. Okay. Who in this class went to St. Mike's Elementary School? Raise your hand. Okay. So we have 2 students who went to St. Mike's. So it says, what is the probability of selecting a student in our class that is left-handed? 1 in 12. Probability of a left-handed student is 1 over 12. What is the probability of selecting a student in our class that went to St. Michael's? 2 over 12, which is another way of saying 1 over 6. What is the probability of selecting a student from our class that is left-handed and who went to St. Michael's? 0. This doesn't really work when you have small numbers. Ben. Okay, let's try. Okay, Canadian Martyrs. How many of you are from Canadian Martyrs? Let's just fix this up. How many of you are from Canadian Martyrs? Raise your hand. Okay, 1, 2, 3, 4, 5, 6. Ben, that's so rude. That's still rude. Okay, so it says here, so we'll maybe change this up. What is the probability of selecting a student from our class that is, we'll fix 1B. So the probability of being from Canadian Martyrs is what in this class? Six over 12, which is, so half of you today have went to Canadian Martyrs. So what is the probability of selecting a student from our class that is left-handed and who went to Canadian Martyrs? Anyone? Not 1 over 6. What is the probability of selecting a student from our class that is left-handed? 1 over 12. It's not a conditional probability. So the probability of left-handed and went to CM is 1 over 12. Okay, the next one here says, what is the probability of selecting a student from our class who is left-handed or who went to, we'll do CM. So I want to figure out this, the probability of a left-handed or went to CM, Canadian Martyrs. What do you think I would do for this? Anyone? This isn't new. What? Guess what? Okay, so right now I have the probability of being left-handed, and you said I'm going to add that with the probability of the students who are from CM. Would that give me my correct answer? Right, the student who's left-handed and who went to Canadian Martyrs. Okay, so that's the OR case. So there's a subtraction piece here. So I have for my left-handed student, I have 1 over 12 plus 6 over 12. And then again, I'm going to minus that 1 over 12. because there was one person who went to Canadian Martyrs and who's left-handed. So that gives me a probability of 6 over 12, which is 0.5. It won't always be, it just happens to be in our example right now that this and this is the same. It'll obviously vary if there was a left-handed student in this class who did not go to Canadian Martyrs. So that just happens to be a coincidence with our data here. Does anyone have any questions? Okay, so that was kind of a review on what we've done so far. So the next piece here, what is the probability of selecting a student that in our class that is left-handed? We know what that is. That probability is 1 over, oops, the probability of left-handed is 1 over 12. What is the probability of rolling a 4 on a die? So that's 1 dice. What's the probability of that? 1/6. There are no connections between the two data. There's absolutely no connection of whether or not rolling a dice of 4 and the probability of picking someone who's left-handed in our class. So it says these events are considered independent. Independent events are 2 events that have no effect on one another. There's no connection there. What is the probability of selecting a student from a class that is left-handed and rolling a 4 on the die? Okay, it says here, the word "and" indicates we are looking for the intersection of the 2 sets. How do we determine the intersection of the 2 sets if the events are independent? Again, I'm going to change this. I have to figure out how to do this. So this is saying we take, for the probability of the intersection of 2, A and B, we take the probability of A and we multiply it by the probability of B if events A and B are independent. So if I want here, what is the probability of choosing a left-handed student and rolling a 4? Those events are independent. So I would take my 1 over 12, which is the probability of me picking a left-handed student in this class, and multiply it by 1 over 6, which is the probability that I roll a die, and I end up getting 1 over 72. That's the probability of selecting a student from a class that is left-handed and rolling a 4 on the die. Any questions with that? Okay, a mutually exclusive is not the same thing as independent. Mutually exclusive events are events that can't happen at the same time, i.e. having a green eye and a brown eye. Independent events are events that have absolutely no effect on the outcomes of each, i.e. being left-handed and rolling a 4 on the die. So we're going to look at some examples here. What is the probability of flipping a head? Billy, can you help me out? Good. The probability is flipping a head is 1 over 2, which is saying 50%. What is the probability of flipping a head if you just flipped a head a moment ago? Pat, what do you think you would put for that? What is the probability of flipping a head given, or, you know, if you just flipped a head a moment ago? Yeah. The last flip that we just did has no bearing on what we just did. So the last flip has nothing to do with the first flip. Okay, so those events are independent. What is the probability of selecting a student from the class that is left-handed or rolling a 4 on a die? So again, here, as soon as I have this OR case, this is saying the probability that you are left-handed or you roll a 4 is equal to the probability that you are left-handed plus the probability that you roll a 4 minus the probability that you are left-handed and you roll a 4. So my probability of being left-handed was 1 over 12. The probability of rolling a 4 was 1 over 6. Minus the probability that you are left-handed and roll a 4, what was that, Natalie? 1 over 72. So Mike, when I put all of this in my calculator, what do I get for an answer here? Good, so it's like saying 17 over 72, which is another way of saying 0.2361. We'll always round to 4 decimal places when you have the percent. So again, it's just going over the or, the and, independent events. These are the examples here. Okay, our last one here. Chris figures that he has a 60% chance of passing math and that Ty has an 80% chance. You done? Okay. What is the probability that they will both pass? So I want the probability that both Chris and Ty pass. Michaela, what do you think you would do for that? Yep. I multiply the two probabilities together. They are both independent events. So Chris and Ty, so when I multiply them together, Spencer, what do I get? Good, 0.48, which is like saying 48%. Okay, and I'm going to tell you now, you will see a question like this on your test. So it says here, Chris will pass, but Ty won't. So the probability, I want Chris passes and Ty won't. That's like saying Ty prime. That's the complementary of that. Scott, what do you think you would put into that formula? What's the probability that Chris will pass? So I know I'm going to write 0.6. And I'm going to multiply by what's the probability that Ty won't pass? Thanks, Scott. 0.2. And can you explain where you got that from? Pardon? You should. Go ahead. You can explain it, though. Where'd you get the 0.2 from? There's an 80% chance that he'll pass, so there's a 20% chance that he's going to fail. So 100 minus 80 gives you 20%, 0.2. So that gives you a 0.12, which is 12% chance that Chris will pass, but Ty won't. Okay, David, I want the probability that they will both fail. So that's saying the probability of C prime and the probability of that T prime. So what would I plug in for that? Very good. And the probability that they both fail, what is that percentage? Joanna? Very good. Which is saying there's an 8% chance that they both fail. Okay, the last one here. What is the probability that at least one of them passed? There's two ways you can do this question. when we're doing this. There's the indirect way and the direct way. One is more work, the other one isn't. Does anyone know, okay, at least one of them passes. So the indirect way would say I need to find when none of them pass, and I subtract that from the whole. So it's like saying 1 minus the probability that Chris doesn't pass and Ty doesn't pass. If I find that probability, which we already know what it is, it's 8%, 8% that both fail, then that means the rest of that percentage is when one or both pass. So that's saying 1 minus 0.08, which gives you 0.92, which gives you 92% that at least one of them will pass. Okay, the direct way of thinking of this question, at least one of them passes. So we can look at the case when Chris passes, Ty doesn't, or Chris doesn't and Ty does, or Chris and Ty both pass. So remember that prime is saying the opposite, the complementary of that. So Dylan, can you help me out here? What would I put in for this first piece here if Chris passes and Ty doesn't? Very good. Plus, Noah, what am I going to put for when Chris fails and Ty passes? Good. And Billy, the probability that Chris passes and Ty passes? Very good. 0.6 times 0.8. When you plug all that into your calculator, you'll get 0.92, which is another way of saying 92%. So these are two different ways to get the same answer. Does anyone have any questions about this? Okay, this is a short lesson for today.